everybody, welcome to our 12.3 lecture video on logarithmic functions. So today we're going to talk about logs. Logarithmic functions are the inverse of exponential functions, which we just finished talking about. So let's start there. So an exponential function would look like this: y equals 2 to the x. And it's a one-to-one function, therefore it has an inverse. And you guys remember, to get an inverse, you always just switch your x and y values. So the inverse would look like this: x equals 2 to the y. And we're just going to do a quick graph. Okay? So for y equals 2 to the x, let's make a nice little xy chart and graph it. So I'll pick some nice easy x values. How about -2, -1, 0, 1, and 2? If x is -2, I would have 2 to the -2nd, which is the same thing as 1 over 2 to the 2nd, and 2 squared is 4, so that would be 1/4 for my y value. If x is -1, I would have 2 to the -1st power, which is 1 over 2 to the 1st, so that would be 1/2. If x is 0, that would be 2 to the 0, and anything to the 0 power is 1. If I have x is 1, that would be 2 to the 1st, which would be 2. And if x is 2, that would be 2 squared, which would be 4. So now I've got these nice points, and we can graph them. -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. And we can make a nice smooth curve to connect our dots. And we found out last time that with the exponentials, one side is going to go towards the x-axis. It will never quite touch it. It's just going to get very, very close to touching it, okay? The other side goes up very, very, very quickly, okay? So let's look at the inverse and see what happens there. So for the inverse, x equals 2 to the y, all I'm going to do is switch my x and y from the coordinates that I've already found. So instead of -2, 1/4, I'm going to have the point 1/4, -2. Instead of the point -1, 1/2, I'll have the point 1/2, -1. Instead of 0, 1, I'll have the point 1, 0. Instead of 1, 2, I'll have the point 2, 1. And instead of 2, 4, I'll have the point 4, 2. And we can plot those. So let's see here, we got 1/4, -2 is about here. 1/2, -1 would be right there. Got the point 1, 0, which would be on the x-axis. 2, 1 is just above the axis, and 4, 2 would be right here. So connecting our dots to make a nice smooth curve, look kind of like that. So instead of going towards the x-axis on one side, now we're going towards the y-axis. Instead of going up very, very quickly, now we're going right very, very quickly. And that's what the inverse function looks like. So then the question is, well, what if I want to solve for y? What if I want to get it in function notation? You can do that. And that's where logarithms come into place. Logarithms are the inverses of exponentials. So if I want to get rid of that 2, that's a base, you're not going to divide by 2 because it's not multiplication. You're not going to square root it because it's not squared. We're going to take a logarithm, okay? And the specific log that we would take would have a base of 2 to get rid of a base of 2 from an exponential. And so let me show you what that looks like. So we start out with x equals 2 to the y. And to get rid of that 2 as a base, what you would do is take the log base 2 of both sides. And so the log base 2 and the base of 2 from an exponential are opposite operations. They undo each other, and you're left with y. So log base 2 of x equals y. That's what that looks like. So in general, this is going to be very, very helpful. It's inside the box and inside the bolded part. In general, it looks like this: y equals log base a of x, if and only if, which means it goes both directions, x equals a to the y. So what you'll notice is that y is our exponent, and it'll be y equals. A is the base of our exponential, and a is the base of our log. We have x equals on the exponential side, and x is what's inside of our logarithm over here. So that's what it looks like. Let's practice going back and forth between the two formats. So this y equals log base a of x, that is logarithmic form. X equals a to the y is exponential form. So we just want to practice going back and forth between those two formats. So the first one I have is 8 squared equals 64. So in log form, my base would be 8, just like 8 is the base of my exponential. It's going to be log base 8 of 64 equals my exponent, which is 2. Okay. Let's do another one. So I've got 10 to the negative first equals 1/10, which is a nice true statement. Let's go from there, okay? So I'll have log with a base of 10, because that's the base of my exponential, of 1/10, and I'm just using a parenthesis so I know that the whole thing is inside of the logarithm, equals my exponent, which is -1. And 10 is kind of a special number because our number system is base 10. And so with logs, because 10 is so common, it's actually called a common log. So if you ever see a log without a base, it means that it's base 10. So you can actually write it as log of 1/10 equals -1 because it has a base of 10, so it's a common log. Let's go the other direction, okay? So I start out with log base 5 of 125 equals 3. So that means that 5 is my base. It equals 3, so 3 is my exponent. And we're going to equal the thing inside of the logarithm, which is 125. Okay? Let's do one more. Log base 3 of 81 equals 4. So 3 is my base. 4 is my exponent. And it equals 81. Okay? The last 3 lines are for you guys to practice a few. Okay? So I'm going to give you guys 3 of them to try really quick. So let's see, first one I'll have is 4 squared equals 16. That's an exponential form. Try to get it in log form. I'll have 2 to the 5th equals 32. Same thing. It's an exponential form. Try to write it in log form. And one that goes the other way, I'll have log base 9 of 81 equals 2. This one's in log form. See if you can get it in exponential form. So yet again, pause your video and try all 3 of those. And I'll show you the answer in 3, 2, 1. So for the first one, you should get log base 4 of 16 equals 2. For the next one, log base 2 of 32 equals 5. And for this last one, you should have 9 squared equals 81. How'd you guys do? We do okay? Good. The next thing we're going to do is solve some log equations, some equations that have logarithms in it. So one strategy for solving logarithmic equations is actually to use that exponential form that we just finished doing. So one strategy is to change from logarithmic form to exponential form. Because sometimes that makes your life a lot easier. Okay? So let's try a few. In the first one, I have log base 3 of x equals -3. So let's try putting it in exponential form and see if that makes our life easier. So exponential form, we would have a base of 3, an exponent of -3, and it would equal x. And that one actually works out really nicely because I have x equals, right? So I've already got x by itself. I just need to tell me what 3 to the -3 equals, okay? So remember that a negative exponent is 1 over. So it'll be 1 over 3 to the 3rd equals x. And 3 times 3 times 3 is 27. So that would mean that x is 1 over 27, or 1/27. Okay? For the next one, part B, I've got log base 1/3 of 2x plus 5 equals 2. So let's try getting it in exponential form and see if that makes our life a little bit easier. So the base would be 1/3. It's raised to an exponent of 2, and it equals 2x plus 5. Alright, that doesn't seem too bad. That's a nice linear equation. So 1/3 squared would be 1/3 times 1/3, which is 1/9. And then if I want to get x by itself, I'll probably subtract 5 and then divide by 2. So let's do that. I'll subtract 5 first. So 1/9 minus 5, I need a least common denominator, which would be 9. And 5 would be 45/9. 1/9 minus 45/9 would be negative 44/9. So now I've got negative 44/9 equals 2x. Then I need to divide by 2, and remember, dividing by 2, that's the same thing as multiplying by a half. So let's see, the 2 and the 44 are going to simplify pretty nicely to 22 and 1. The 2's divide out on the right side, so I'm going to have x equals negative 22/9, and we're done. Let's see, in part C, I've got log base x of 5 equals 4. This time I'm solving for the base. Let's see if exponential form helps us. So in exponential form, I would have a base of x, an exponent of 4, and it would equal 5. Okay? So this one, we're trying to get x by itself. It's raised to the 4th power, and we know how to do that. Just take the 4th root of both sides, right? So take the 4th root of both sides, undo the 4th power. So I'll have x equals the 4th root of 5. It is technically plus, positive, or negative because of it being an even power. Okay? And that's it. Last one over here is log base 6 of the 4th root of 6 equals x. So let's change that to exponential form and see how that goes. So in exponential form, my base is 6. My exponent is x, and it would equal the 4th root of 6. Well, since I'm in exponential form, let's use exponents. So remember from our rational exponent unit, the 4th root of 6 would really be 6 to the 1/4 power. So now I have 6 to the x equals 6 to the 1/4. And from exponentials, which we just finished last section, if you have two exponential expressions, they're equal to each other and they have the same base, you know the exponents have to be equal. So we'll know that x has to equal 1/4. And that's it, okay? I'm going to start with example 2 in the next video. So tune in for part 2, and I'll see you in a little bit.